We have one data type left in our interpreter, which is value. And there are two variants, number and closed C. What are the operations on value? It turns out there are two operations. One operation on value is that we apply a value. You see that in the type case here inside of appc. And the other operation is that we need to extract its number out. And that operation is not represented by a type case, but it's really here where we are doing a dispatch based on the type of the number, and another dispatch here. So this idea that we have two operations on particular objects that are values is a problem for our encoding, because our function encoding really assumes that there's only one operation, right? An area operation. In the case of shapes, if we wanted to add an operation like perimeter, now we're stuck because all we can do is call the function. A way around this, a possible way around this, is to, when you call the function, pass in a symbol that says which operation you want. So this is a very literal translation of the idea that you pass an operation to an object. So if I make a shape, take a symbol, and return a number, then I can pass the symbol area to get the area of the rectangle, or perimeter to get the perimeter of the rectangle. And the implementation would look something like this. Rectangle takes a width and height and returns an object that takes an operation as an argument. And if it's area, then it returns the area, and if it's perimeter, then it returns the perimeter. Square is the same. It recognizes area and perimeter and performs the requested operation. Now, this approach works when we have functions like area and perimeter that always return the same kind of value. What if we wanted to have a function, though, an operation on objects that says, is the object bigger than the given amount? In that case, we need to pass the operation in, but also a number, and what we want to get back is a Boolean. So this is not going to work out well, again, with this encoding, and in fact it has problems with a typed encoding at all. So what we're going to do to look at this is switch to an untyped variant of PLAI for a while, and look at an implementation where instead of having an object as a function that takes a symbol, we're going to have an object as a hash table that has a name mapped to a function. Let's look at hash tables just for a minute in PLAI. When you say hash, then that constructs a hash table, and a hash table is kind of like a list, and that if you give it no things, and you get a hash table with nothing inside of it. It prints out like that. But if I say hash quote x1, then I get a hash table that maps x to 1. And in particular, if I bind that to ht, then I can use hashref to look up the value for x in that hash table. And I can add another mapping y, which is 12. And so if I look up x, I will still get 1. And if I look up y, then I'll get 12. And these things don't have to be numbers, they can be any kind of value, so it could be a function that returns 19. Now when I look up x, I get a procedure back. If I call that function with no arguments, then I'll get the 19 out. So that's what we're going to use to represent objects. So the name area and the hash table will be mapped to a function that just returns a number, and a bigger than method in this hash table can be mapped to a function that takes a number and returns a Boolean. And we can implement rectangle like this, build a hash table with area and bigger than mappings, where the bigger than mapping takes a number and checks whether the area is bigger than that number. To call a method now, we have to use the object as a hash table, pull out something with the right name, and then apply the result of that. So there are two right parentheses here. That's because this one is the hashref parentheses. It pulls out the area function. This one calls the area function. Similarly, this parenthesis pulls out the bigger than function, and this parenthesis calls the bigger than function with the argument 100, and because 100 is less than 150, or because 150 is greater than 100, then we get a true value back.